A disposition status flag can be set to identify which files need to be disposed. The action that is to be performed on a file for disposition can be marked for later execution. A disposition flag can be set for the action to be performed. In a separate rule, a check for the disposition flag can be made and the file can be processed. Example disposition actions are aggregation, wait until enough data are ready and then process the file. This is used with caches to support aggregation of files into a container before writing to an archive. Migration, support delayed transfer of files to an alternate storage system. This is used for migration from archives where tape latency is large. The rule testsetDisposition.r sets a disposition AVU attribute to 1 to indicate processing should be done. The input parameters and operations that are performed by the rule include the input parameter is $call, the collection that is analyzed. The session variables are $rodzone client and $username client for the data grid name and the username. The persistent state information that is used is the collection ID and name and the data name for the file. The metadata internal identifier for a metadata attribute disposition, the metadata attribute name disposition, and the metadata attribute value, which will be set to 1. A policy function is used, check call input, to verify that the collection exists. The operations that are executed are fail, which forces termination in case of bad input data, for each, looping over each file in the result list from the query, if a conditional test on the value of the disposition AVU, MSI associate key-val pairs to object to add metadata to a file, MSI remove key-val pairs from object to remove metadata from a file, MSI string to key-value pair to convert a string to a key-value pair, select to generate the query, and write line to write an output line. The rule shown here is testsetDisposition.r. The rule is available at LifeLibZone Home RWMore Rules testsetDisposition.r. The rule checks the validity of the input collection name, then creates a query to list all files in the collection. For each file, a search is made for the metadata attribute disposition. If the attribute already exists and has a value of 0, it is deleted and replaced with the value of 1. If the attribute does not exist, it is created. The rule test archive.r checks for files with an attribute disposition with a value of 1 and copies the file to an archive. The rule is available in LifeLibZone Home RWMore Rules test archive.r and is shown here. The rule uses 5 input parameters. *res is the storage location where a report will be written. *dest_zone is the data grid zone where the report is written. *account is the file owner. *source is the source collection. And *destination is the archive collection. The rule checks that the input collection names exist, gets the current time, and creates a time-stamped log file. A query is made for all files in the source collection and its sub-collection. A loop is then done over the files. A query is made to get the disposition flag for each file. If the disposition flag is 1, the destination path name within the archive is constructed. The path name mimics the sub-collection structure in the source directory. The sub-collections are created in the archive if necessary, and the file is copied into the archive. Access controls are set for the owner on the archive file. After the copy, the checksum of the file is validated. Take 7 minutes to complete exercise 88. Decide how you would modify the rule LifeLibZone Home RWMore Rules test-archive.r to serve as a disposition policy for your collection. What actions would you apply instead of archiving? Please load a paragraph describing your decision into the Lifetime Library in the subcollection class INLS 624 by the end of today's class. The NASA Center for Climate Simulations, NCCS, is using policy-based data grids to federate multiple federal data collections. Federal repositories provide mechanisms to manage the publication of data. The tasks include managing ingestion of observational data, supporting ingestion from multiple geographic locations, organizing the data sets into collections, managing preservation information including provenance, providing mechanisms to publish the data sets. A climate data server can facilitate data sharing by providing services that are needed to make the data useful to a research project. A climate data server takes data from federal repositories, maps the data to a standard coordinate system, transforms the data to the desired physical variables, and produces a standard registered dataset for use in research. The NASA Center for Climate Simulation has developed a climate data server that supports the publication requirements of the Intergovernmental Panel on Climate Change. The data server is based on the IROD's data grid. NCCS examined the challenges in organizing multiple types of observational data collections for publication. They presented their approach at an IROD user group meeting. The goal was to show that multiple independent observational data sets could be individually managed and then federated for access by climate data servers. NCCS initiated a data management system project to prototype repositories for multiple types of sensor data. Their approach was based on the construction of an IROD's data grid testbed and the retrieval and management of 4 existing data collections. They developed additional capabilities required by NASA and automated the data processing steps. Some unique requirements included the ability to maintain audit trails of all actions performed upon the data collection, even for data sets that were deleted, the management of the audit events independently of the data grid, the specification and storage of descriptive metadata attributes needed for each observational data set in a separate database. The federated data grid approach is shown here. 4 data grids were implemented, one for each observational data set. The data middleware was installed on existing storage systems to provide a controlled namespace for the federation. The 4 data grids were federated to enable controlled access from a single client. The descriptive metadata for each collection could be browsed and the files could be organized into collections independently of the storage location. The 4 observational data sets included multiple types of data, ranging from satellite images, moderate resolution imaging spectroradiometer, MODIS, to invasive species maps, to reanalysis datasets of satellite data from GEOS-5 to simulation output. The largest collection was the MODIS dataset with 630 terabytes of data and 300 million metadata attributes. The metadata had to be searchable from a web client and provide rapid response. The data grid federation simplified the construction of a climate data server by providing uniform access to all 4 data collections. In a second generation of development, the climate data server was generalized to support access to additional federal repositories. This required developing the data transformation methods needed to handle each of the data types that were retrieved, map the data to the same coordinate system, and deliver a standard data product to the users.